This is Chemistry Made Simple YouTube channel. I take this opportunity to welcome you to another great learning opportunity. Today we look at the concept of isomerism in organic compounds. First things first, what is the meaning of the word isomerism? Isomerism can be defined as the existence of organic compounds, for that case, with the same molecular formula but different structure formula. So, what really causes organic compounds to have the same molecular formula and different structure formula? Well, two reasons can be used to account for this. The first reason is that organic compounds may have the same molecular formula and different structure formula due to the difference in arrangement of elements in the compounds. And number two is that organic compounds may have the same molecular formula, different structure formula for that case, due to the difference in spatial arrangement of elements in the compound, or some other sources of chemistry literature call this three-dimensional arrangement of elements in the compound. Consequently, compounds having the same molecular formula, and in this context I mean organic compounds, but different structure formula, are generally known as isomers. Now, the whole concept of isomerism is subdivided into two major classes, and the first class is constitutional isomerism, which will yield constitutional isomers, and the second class is stereoisomerism, which yields what is known as stereoisomers. I take this opportunity to welcome you to the first class of isomers, which is constitutional isomerism. What is the meaning of constitutional isomerism, or what are constitutional isomers? Constitutional isomerism is defined as the type of isomerism or the class of isomerism in which isomers have the same molecular formula but different structure formula due to the difference in arrangement of elements in the compounds. So, constitutional isomers are compounds of the same molecular formula but different structure formula due to difference in arrangement of elements within the compounds themselves. Constitutional isomerism, therefore, is subdivided into three types or classes of isomers. And those classes or types, whatever you may call it, are number one, skeletal isomers or skeletal isomerism. Number two, position chain isomers, and for that case, position chain isomerism. And number three, functional group isomers or functional group isomerism. Ladies and gentlemen, welcome to the first class or type of constitutional isomers or constitutional isomerism. And we start with functional group isomerism, or for that case, functional group isomers. By definition, is that functional group isomerism is the type of constitutional isomerism in which isomers have the same molecular formula but different structure formula due to difference in functional groups. So, it is possible that compounds can have the same molecular formula but different functional groups. Now, we need to be very careful since not all organic compounds can have exchangeable functional groups. To illustrate, I will mention a few of the functional groups that can be exchangeable with each other. The first that we have is that aliphatic alkenes, those ones are known, or their trademark is the carbon-to-carbon double bond, are functional group isomers with cyclic alkanes. And there is an example displayed there, is that the alkene prop 1-ene can also be a functional group isomer with cyclopropane. Notice that the two, in one of them there is a carbon-to-carbon double bond, while in the other there is no carbon-to-carbon double bond. That marks out the difference in functional groups. The second example to illustrate, displayed beside me here, is that carboxylic acids are also functional group isomers of esters. And displayed there, we do have the carboxylic acid that is generally known as propanoic acid, and the corresponding ester displayed there is methyl ethanoate. Now notice that the two don't have the same functional group and therefore end up being functional group isomers. The third and final example that I have to illustrate this is displayed there as alcohols are also functional group isomers with a group of compounds known as ethers. Displayed beside there is the alcohol that is known as ethanol, and for that case its corresponding functional group isomer on the part of ethers is also displayed there, whose IUPAC name is dimethyl ether. Consequently, the two compounds are not the same since they have different functional groups. With this, we come to the end of our first class, which is functional group isomerism. Ladies and gentlemen, welcome to the second class or type of constitutional isomerism. And this is none other than position chain isomerism. By definition, position chain isomerism is the type of constitutional isomerism in which isomers have the same molecular formula but different structure formula due to difference in the position occupied by a functional group or a substituent. So if we have a compound that has different positions of a substituent or a functional group, then this compound is liable to existing as a position chain isomer. To illustrate position chain isomerism, the example displayed there is well known as pentan 1O. Now notice that the functional group, which is the hydroxyl group or the OH group in this isomer, is on the first carbon. Now, its position chain isomer below displayed inside has the IUPAC name as pentan 2O. Now realize that the functional group, which is the OH group, has shifted from the first position to the second position. We can also have another position chain isomer, is that displayed there, the third compound besides. Realize that its IUPAC name is pentan 3O, and consequently the position of the OH group is changing. So to conclude this concept of position chain isomerism is that in position chain isomers or isomerism for that case, there is difference in the position that is occupied by a substituent or a functional group. This takes us to our third and final class of constitutional isomerism or constitutional isomers, and this is what is known as skeletal isomerism. What is the meaning of skeletal isomerism? By definition, skeletal isomerism is defined as the type or class of constitutional isomerism in which isomers have the same molecular formula and different structure formula due to difference in carbon-to-carbon chains. So, if you find two organic compounds having the same molecular formula and different carbon-to-carbon chains or carbon-to-carbon skeletons, then you are very much free to refer to these two organic compounds as skeletal isomers. To illustrate this, we have normal butane, which is displayed there, and its corresponding skeletal isomer, isopropyl butane. Now notice that the two have the same molecular formula, but different carbon-to-carbon skeleton. With this, let me welcome you to the classroom in which we shall try to answer one of the examinable questions about the whole concept of constitutional isomerism. Ladies and gentlemen, this is the classroom, and the question that we are discussing here is that we are supposed to write down the structure formula of isomers. So we shall be writing down the structure formula of all the isomers that are associated with an alkene. But we know its molecular formula has been given. So this given information here is the molecular formula of the alkene. So we start by writing what is generally known as the straight chain isomer. And we have to remember that this is an alkene and therefore must bear a carbon-to-carbon double bond. So our first isomer is therefore so that is our first isomer, whose IUPAC name should now be very simple for you to generate. The second isomer we can obtain from here by varying this carbon-to-carbon double bond, and therefore as the structure, this one also by naming it according to IUPAC, the name ends up as but2-ene. And the third isomer can generate from any of these two by reducing the carbon chain and creating a substituent. So if we are to reduce the carbon chain and create a substituent, we shall have now realize that our carbon chain now has 3 carbon atoms as compared to that one, also whose name according to IUPAC is the name then, as stated previously, is that alkenes are functional group isomers with what is known as cyclic alkanes. So for that case, we have this isomer here, whose systematic name is and finally, from this, we can also write another cyclic isomer or cyclic alkane whose IUPAC name is Now, consequently, these two have different functional group as compared to these first two because they don't have the carbon-to-carbon double bond. As a matter of emphasis, I would like to emphasize that these two are what we call position chain isomers. Why? Because they have difference in position occupied by the carbon-to-carbon double bond, and this one, as compared to the first two, is what we could call a skeletal isomer. Why? Because it has a different carbon skeleton as compared to these two. And finally, the last two, since they have different functional group as compared to the first two, are what we can call functional group isomers. At this point, I therefore once again thank you for being part and parcel of this great learning opportunity. I remain yours truly, the chemistry teacher. Goodbye.